The Tragically Hip held their last concert in Kingston, and 15,000 people attended. Tickets cost $85 for students and seniors and $125 for adults. The concert took in $1,625,000 in ticket sales. How many adults went to the concert? While the question is only asking us about the adults, there are actually two unknown pieces of information: the number of adults and the number of students and seniors who attended the concert. So let's use the variable x for students and seniors and the variable y for adults. Now let's think about the information that we know. The total number of students and seniors plus the number of adults equals 15,000 people, x plus y. We also know that the students and seniors paid a rate of $85 and the adults paid a rate of $125, and together that is a total amount of $1,625,000. So 85x plus 125y is equal to 1,625,000. Now both of these equations can be used to graph a linear representation. And while we can reorganize the equations to be put into the standard form of y equals and so on, we can actually put these equations as is into the graphing program Desmos. When we graph these equations, we are looking for the point of intersection where they meet. This will tell us that all conditions of this problem have been met, meaning the total number of people is 15,000 and the balance between them makes a total ticket revenue of $1,625,000. When each of those equations are put into Desmos, we get the following graph. Let's label the axis to help us keep track of our information. Our x is our number of students and seniors, and our y is our number of adults. You'll notice on the screen capture of the graph that I've marked the point of intersection with its coordinates, 6,250 and 8,750. Remembering that the coordinates are listed x then y, alphabetical order, we know that the second piece of information, 8,750, or the y, is the number of adults at the concert. Now, this option of graphing is great if you've got graphing software like Desmos on hand, or if you're dealing with smaller numbers and can do it by hand. But it is also possible to solve this problem algebraically. So, let's think about this. If the number of students and seniors plus the number of adults is equal to 15,000, then it would be true to say that the number of students and seniors is 15,000 subtract the number of adults. If we know that 15,000 minus y is the same thing as x, we could actually use this information in our other equation about the cost of the tickets, so that then we're only dealing with one unknown. Now that we've replaced the x in this equation with our new information about x, we can start to solve it. If we were to multiply the $85 ticket fee by all 15,000 people in attendance, you would get $1,275,000. But we would also need to multiply that $85 ticket by our negative y, meaning that we would be subtracting the number of adults, since that's not how much they paid for the ticket. We will then subtract the possible price per ticket if everyone in attendance had paid $85 a ticket. That means $1,625,000, the total amount, minus $1,275,000, which gives us $350,000. This $350,000 is paid for by the adults who actually purchased their tickets for $125. Now, if we look at the difference between the price the adults paid and the price that the students and seniors paid, that's $125 minus $85. That gives us $40. There's a price difference of $40 per adult who came. So this amount left over, $350,000, is accounted for by the $40 price difference each and every adult paid. So we need to figure out how many adults that is. $350,000 divided by the $40 price difference gives us $8,750. This means there were 8,750 adults in attendance who each paid $125 per ticket.